Today, yung objective natin for this set of lessons is to build up to the idea of the definite integral. And we'll start by discussing the area problem. So the area problem is sort of like this. Let's say I have a function, f of x. In our case, f of x equals the quantity x minus 1 squared plus 1. Tapos, gusto kong mahanap yung exact area nung region bounded by x equals 1, x equals 5, our function, and the x-axis. Formula para i-compute yung exact area niya. So at this point, we'll just have to settle for an approximation. So let's say we want to approximate the area of the region bounded by f of x, the lines x equals 1 and x equals 5, and the x-axis. So that region is given by the shaded area, yung kulay green. Gusto nating mahanap yung area niya. Again, wala tayong formula, so we'll just use approximation methods. And we will use rectangles para i-approximate yung area niya. At the start, let's use 4. 4 rectangles determined by n equals 4, na equal yung width para i-approximate yung area. Since yung base nung area na gusto nating i-measure is from 1 to 5, that is 4 units, if we are using 4 rectangles na equal yung width or base, then we should be able to compute for that base na lahat sila equal to 1. So, ang denotation natin for the width or the base of these rectangles ay delta x. So, yung base nila delta x, for n equals 4, delta x is equal to 1. So, pantay-pantay sila lahat na delta x. And yun nga, equal sila lahat sa 1. Okay, note that here we are using the leftmost endpoint of each subinterval para mahanap yung height ng bawat rectangle. What do we mean by that? So, let's take a look. Itong rectangle na to, yung first rectangle natin, yung height niya, determined kung ano yung value ng function dun sa leftmost point ng subinterval. Since yung leftmost nung interval na yun ay 1, yung height niya ay given by f of 1. Ito naman, yung rectangle natin sa kanan, yung pinakamalaki, this is equal to 4. So its height is determined by f of 4. Note that hindi tayo restricted sa leftmost endpoint, no? Para mag-approximate ng heights ng rectangles. Pwede tayong gumamit ng any point in the subinterval. We could use, for this case, yung midpoint nung subinterval para i-determine yung height. So, kunyari, itong approximating rectangle na to, para makuha yung height niya, we are evaluating the function at x equals 4.5. So parang ang area nitong rectangle na to ay f of 4.5 times 1. And then ipa-plug in natin dito yung 4.5. Note that for this example, baka mas maganda pa ngang approximation yung midpoint. Kasi makita natin na merong under approximation dito, meaning kulang, pero may over approximation dito, sumosobra. So baka naman itong dalawa na to, they sort of will cancel each other out, even if not exactly, yung total error mas maliit kesa yung kanina natin na under approximated. Pwede rin natin gamitin yung rightmost endpoint. In this case, para ma-determine yung height nitong rightmost rectangle, we are evaluating at x equals 5 kasi siya yung rightmost point ng subinterval na 4 to 5. So it's f of 5 times 1 for this rectangle. Now, for all these 4 rectangles, kung yan yung gagamitin nating approximation, over approximation naman siya. May sumusobra tayo na area na lumalampas dun sa boundary natin sa taas, which is the function. Later on, we'll see that it's okay. It doesn't really matter if our approximating rectangles are overestimated or underestimated as long as yung height nila ay nakukuha natin based sa isang x value dun sa subinterval. So in that case, let's just go back dun sa leftmost point for our example. So using the leftmost endpoint, we will proceed with approximating the area of the region. So it will be given by the sum of the approximating rectangles, yung areas nila. So let's start with the first rectangle, that's f of 1 times delta x plus f of 2 times delta x plus f of 3 times delta x plus f of 4 times delta x. Let's just wait for the animation to catch up. Pero alam natin na yung delta x, lahat sila equal to 1. So, pwede natin na siyang ma-simplify at matanggal para f of 1 hanggang f of 4 na lang. Tapos we could evaluate yung f of 1 plus f of 2 plus f of 3 plus f of 4 kasi alam natin yung function, it's the quantity x minus 1 squared plus 1. So ito yun, yung result after plugging in. Evaluate that, and we'll get an approximation of 18 square units. Pero alam natin na under approximation siya. Kulang yung value na yan. So yung next question is, how do we improve our approximation? Well, we could increase the number of subintervals. Imbis na 4, gawin nating 8. Pero the act of increasing the number of our subintervals, lumiliit yung width nila, yung base ng rectangle na ginagamit natin. So kanina, the base is 1. Ngayon, the base is 0.5. Delta x is equal to 0.5. How did we get 0.5 for delta x? Yung length from 1 to 5 is equal to 4. Tapos we're dividing it into 8. So 4 divided by 8, 0.5. This is still an under approximation, pero nabawasan na yung error. And we could improve this further by taking more subintervals and consequently reducing the width of yung delta x of the approximating rectangles. So here I'm using n equals 20, in which case delta x is equal to 0.2. So this is a better approximation. But remember, this is a calculus class. And what we want to do is to use some technique of calculus na napulot nyo from grade 11 para yung approximate area na to ay maging exact. So before we leave this topic, I want you to think, how do we make the approximation exact? Not just better, but exact. Saktong makukuha natin yung area under the curve from 1 to 5 bounded by the function and the x-axis. So think about it, and we'll continue with this dun sa next video natin. Salamat sa pakikinig.